Okay, today we're going to talk about lesson 100, which is graphing rational functions, and lesson 121, which is graphing cubic functions. These are the last two functions that we have to go over as far as our parent functions go. So let's go ahead and get started. All right, the first one we're going to talk about is the rational function. The rational function's parent function is y equals 1 over x. Call it a rational function. It's a ratio, turns into a fraction. As usual, we're going to start out with our table, and we're going to see what these values do. So, starting out with -1, if I plug in a -1 for x, I get 1 divided by -1, which is going to give me -1. If I plug in +1 for x, I get 1 divided by 1. That's going to give me a 1. Now, those are 2 points on our graph. 1, 1, -1, -1. When I plug in 0, something interesting is going to happen. Can we divide by 0? No, you cannot divide by 0. So we get something that is undefined, and that means that we cannot have any values of 0. So you will have an asymptote. Remember, we talked about asymptotes last time. And this one is going to be a vertical asymptote at 0. It cannot cross that line. Okay? Now, when I plug in -2, I get a -1/2, and when I plug in 2, I get a +1/2. Okay? Now, if I keep plugging in numbers for my x, like a 3 for my x, I would get a 1/3. If I plugged in a 4 for my x, I get a 1/4. If I plug in a 5 for my x, I get a 1/5. Those numbers keep getting closer and closer to 0, but they can never reach 0. That should sound similar to the exponential functions that we went over last time. So this function not only has a vertical asymptote, but it also has another horizontal asymptote. Okay? So when you graph this function, you need to graph the point -1, -1, the point +1, +1, and then you need to graph the two asymptotes. Okay? Once you do that, as far as what our line looks like, we have this fun little shape that I like to call a swoop. So you're going to have a swoop in the upper right corner. I'm going to start next to this asymptote, hit my point, and finish up at the other. Then we also need to have a swoop in the bottom left corner. I'm going to start next to the asymptote, and I'm going to swoop through my point. And we have our rational function. So 2 points, 2 swoops, and 2 asymptotes. Okay, if we click to the next slide here, you can see I've kind of written it out for you. Your graph must include -1, -1, and it must include +1, +1. You also must have 2 asymptotes, 1 horizontal and 1 vertical. Okay, along with that, remember we need to know how our shifts are going to work. So if you have an inside, that causes our horizontal shifts. If you have outside, that causes our vertical shifts. For our reciprocal function, the only way that I'm going to have a horizontal shift is if there is something in the denominator of the fraction. That is the only spot that is the inside. That is the only spot that is the inside. Out in front is the outside. On top is the outside. If there's anything added or subtracted behind it, that is the outside. So again, the only time you are going to have a horizontal change is if there is something in the denominator. Now, our other parent function that we're going to go over is called the cube function. So it's called a cube function because it's y equals x cubed. Okay, I will go ahead and tell you guys now there are no asymptotes with this one. We're going to have 5 points. You're going to need to know those 5 points. If I plug in a -2 into this function, I get y equals -2 cubed. That's going to give me -8. If I plug in a -1, -1 cubed gives me -1. If I plug in a 0 for x, I get 0 cubed, which is 0. 1 cubed gives me 1, and 2 cubed gives me 8. You have to have these 5 points when you graph this function. So when I graph it, 0, 0, 1, 1, 2, 8. And then I've got -1, -1, -2, -8. This function looks very similar to our cubed root function, except instead of going sideways, it's going vertically up and down. Okay, so that is our cubed root function that we have for a parent function. Now, your graph for a cube function must have -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. You have to have these 5 points. Just like with all of our other parent functions, you also need to remember inside is horizontal, outside is vertical. For a cubed root function, anything inside of parentheses is going to cause a horizontal change. Anything out in front of the parentheses or anything added or subtracted behind the parentheses is going to be a vertical change. Okay, real quick, we're going to go through and just graph about 6 examples here. So I'm starting out with a rational function. I've got 1 over x plus 3. So I'm going to include my asymptotes. I need a horizontal and a vertical. I'm going to have my 2 points, 1, 1, -1, -1. And then I'm going to have my 2 swoops. Make sure that your swoops do not cross the asymptotes. Okay, so we've got our parent function down. Now, I need to graph this shift. This +3 is on the outside. So that means it's going to be a vertical change. +3 means I'm going to go up 3. So, my points are going to each move up 3. And then my horizontal asymptote is also going to move up 3. Now my vertical asymptote does move up, but when I graph it, it doesn't look like it does. Okay, so we've got our 2 points and our asymptotes. Now I just need to add my swoops. And that is a shift for the outside. Next, I've got a rational function again. So start with my parent function. I need my asymptotes. I need my 2 points. Okay. And then we need our swoops. Now if I look at this graph here, this +3, that's in the denominator, so that's on the inside. That's going to be a horizontal change. Remember, on the inside, we do the opposite. So since that's a +3, that's going to move me to the left 3. So for this one, my points move to the left 3. My vertical asymptote moves to the left 3. And my horizontal asymptote moves, but it doesn't really look like it does. So once I get my 2 points and my 2 asymptotes down, I just need to add my swoops. Again, make sure they are not crossing the asymptote. And I've got my y equals 1 over x plus 3. Last one for our rational, I have y equals 1 over x. But I've got a negative in front of it. So again, parent function, 2 points. Okay, add my swoops. Okay, now negative outside. That's going to cause a vertical flip. So whatever's up top flips down to the bottom. Whatever's on the bottom flips down to the top, or flips up to the top. Our asymptotes are not going to change. But since I had a point up top, it now moves to the bottom. And since I had a point down below, it's now going to move up. We're drawing our swoops. Okay, so that is an example of what a flip will look like. Remember, your negatives cause flips. Let's look at 3 quick examples of our cube functions, and then we'll be done. Okay, I've got a y equals x cubed minus 3. Parent function is 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. I know the point is off the graph, but you still have to graph it. I need to have 5 points for this function. So there's my parent function. My minus 3 is on the outside. So that is vertical. Okay, and a minus 3 means I'm going to go down 3. Okay, so each of my points are now going to shift down 3. There we go. And then this one is really far down off the screen. So we've got that. And yeah, try and make that hit. My fault. All right. Next, I've got a y equals x minus 3 cubed. Okay. Notice that minus 3 is inside the parentheses. So we know inside is horizontal. But first, let's start with our parent function. Got my 5 points down for my parent function. Okay, we said that negative 3 is on the inside because it's inside of the parentheses. So inside, that's our horizontal. Okay, remember we do the opposite. So even though it says negative, we are going to go to the right 3. So each of these points will shift to the right 3 spots. Okay, so this is an example right here of what a horizontal shift will look like. It's inside of the parentheses. And then our last one, I've got y equals negative x cubed. Parent function is still x cubed. 0, 0, 1, 1, 2, 8, negative 1, negative 1, negative 2, negative 8. Okay. Now my negative, that causes a flip. Notice the negative is inside of the parentheses, and inside is horizontal. So I'm going to have a horizontal flip here. Whatever's over on the right flips over to the left. Whatever's over on the left flips over to the right. So my top part is going to change sides, and my bottom part is also going to change sides. Okay? So that is what a horizontal flip will look like. Now, I believe you guys have about 8 practice questions. So go ahead and do those 8 practice questions and then make sure that you get them checked when you finish up. Thank you.